Okay, so section 2.5 talks about linear functions and models. We've been talking about linear functions the whole time. This is just going to further that discussion. That's the point. Okay, so definition: a linear function is a function of the form f of x equals ax plus b. The graph of a linear function is a line with slope a and y-intercept b. A lot of you learn it where instead of a you have what? M. Feel free to write m if you don't want to write a. This really does not matter which one you write. If you feel more comfortable seeing that as mx plus b, then you write it as such. Okay? I'm okay with that. All right? So now, note that the graph of a linear function is a line with slope a and y-intercept b. Okay? Example 1, we want to determine whether the given function is linear. If the function is linear, we want to express the function in the form f of x equals ax plus b. Okay? So f of x is equal to 2 minus 4x. So we should rewrite it and put it into this form. Whenever we do that, how do we write it? Negative 4x plus 2. Good. What's a? Is that linear? First of all. Yes, it is linear. What's a or m? Negative 4. And what's b? 2. Good. That's it. Part B. F of x is equal to the square root of x plus 1. Is this linear? No, it's not linear. Very good, because the exponent on x is not 1. What is the exponent on x here? 1/2. Very good. So this is not linear. That is not linear. Okay? Very good. So you'll see problems in your homework set that are just like this. Example 2. Example 2 is in fact number 18 from your homework set. This is number 18 on page 195. Here, I want us to sketch the graph of h of t equals 1/2 minus 3/4 t. What is the slope of the graph? What is the slope of the graph here? Go ahead. Very good. So the slope, a or m, whichever one you want to write, is negative 3/4. So that's our slope. Now, in order to graph it, we can find values of t and then find out what the corresponding h of t will be. Whenever, you can choose whatever values you like. I'll choose negative 2, negative 1, 0, 1, and 2. Whenever we have x or t is negative 2, we substitute in negative 2 here. And what do you get for h of t? Do you need me to write that out? Yes, you said? Okay. So you get 1/2 minus 3/4 times, let me do that on the side, just so I can write it a little bit larger. So we would have 1/2 minus 3/4 times negative 2. Negative 2 is really negative 2 over 1. So notice that the 2 cancels out here, and you're left with negative 1 there. So this is 1/2 plus 3/2. That gives you 4/2, or what? 2. So when t is negative 2, we get 2. Okay? Now, we can find the remaining values or you can use your slope. Do you know how to use your slope? That's a question. Talk. Yes, how do you use your slope?
It's rise over run.
Very good. It's rise over run, so
Of me?
yes.
So it's, you would go down 3.
So 1, 2, 3. So go down 3, so we would be here in -1. So you said go down 3.
And over 4.
So 1, 2, 3, and over 4.
Yes.
1, 2, 3, and 4. So we're right here. And when we're there, x is what? 2, right? And then what you can do is you can sketch your graph. And we need 2 points. And that's your line. Very good. Very good. Okay? For the linear function f of x equals ax plus b, the slope of the graph of f and the rate of change of f are both equal to a, which is the coefficient of x. When a linear function is used to model the relationship between two quantities, the slope of the graph of the function is the rate of change. It is the rate of change of one quantity with respect to the other. Okay? So now the last example is an example of a real life situation that involves a linear model. Okay? So a large koi pond is filled from a garden hose at the rate of 10 gallons per minute. Initially, the pond contains 300 gallons of water. Find a linear function v that models the volume of water in the pond at any time t. Yes?
Would it be v equals 300x plus 10, or I'm sorry, 10x plus 300?
But our variable isn't x. It's what?
Would it be then 10v plus 300?
10 what?
10v plus 300?
Where's b coming from?
This is linear function v.
Says find a linear function v that models the volume of water in the pond at any time t. So what's our variable here? T. Good. So it's v of t equals, your equation is right, you just have to use the right variable. V of t equals 10t plus 300, because 10 is your rate, 300 was what it initially contained. Okay? So your rate is the same as your slope. Now, if the pond has a capacity of 1,300 gallons, how long does it take to completely fill the pond? So here, I'm asking you to find what? T, very good. I'm asking you to find T. But in order to find T, you have to use part A. That's your V of T. So you would have 10T plus 300. What would that be equal to? 1,300, good. So you subtract 300 from both sides. You get 10T equals what? 1,000, good. Divide both sides by 10. T equals 100. So it will take 100 minutes to fill the pond. And there you go. That's section 2.5. Have a wonderful weekend. Make sure you work through your homework, and I'll see you on Monday. Yes?